Hey everyone, welcome to Tutoring. I hope you're having a great day. Today we are doing question 12 from chapter 6C. This is actually the first tutorial video on differentiation, so this is actually a great milestone for this channel. Right, aside from that, let's get into the question. Question 12. Let fx equals the cos inverse of 6 over x. So you can already see why I picked this question to be in the tutorial video. It's because this equation right here is actually abnormal. It's not your typical inverse circular functions. So part A, B, and C, they want you to find the maximal domain of this graph. They want you to find the derivative, and we need to also show that the derivative is always positive for x bigger than 6. And then for part C, we want to sketch the graph labeling endpoints and asymptotes. So let's get into the question. Part A. Part A is actually quite intriguing. Finding the maximal domain of f. So the technique that I always recommend every special students to do is you put the function inside the trig in the middle, in between -1 and 1, okay? So if you want to know more about this technique, I recommend you check the video below or on the cards above. So if you want to check that out, I recommend you watch that video first and then come back to this. Right, so this question is actually quite tricky, and that's because x is on the denominator. So with inequalities, and whenever you have denominators, it works a bit differently. You want to split, okay? So you want to split this into two equations or two inequalities so that it's easier to work with. It's actually, in fact, you should always do that, or else it'll look really messy. Okay, and then the next step is, here's the common mistake. Students would bring x to the left-hand side. I know I did that, and I know most students would do that too. But with inequality, you actually want to flip, okay? You do not want to bring x to the other side, you want to flip instead. That is actually the correct way of doing it. So if I flipped -1, another way of writing -1 is -1 over 1. If I flip that, I'll get 1 over -1, which is still -1. So that's why 1 is our favorite number, along with 0. Okay, I flip 6 over x as well, so that would give me x over 6. And whenever you flip, guys, you also flip the sign, okay? So here's an example. If I have 1 smaller than 10, right? 1 smaller than 10, another way of writing that is 1 over 1. Okay, if I flip this, flip 1, I'll get 1. If I flip 10, I'll get 1 over 10. Okay, so 1 is smaller than 10, but when I flip things, the sign, look at this, 1 compared to 1 over 10, that should be 0.1. 0.1 is actually smaller than 1, so the sign actually flips as well, okay? So that's just an example to demonstrate why you should flip and why the sign should change as well, okay? And then you solve for x as per normal. X in this case would be smaller than -6. So I'll just write it here, x smaller than -6. This is the same, I flip this, x over 6, the sign changes, 1 flipped is still 1, and then x is therefore bigger than 6. So our domain for the graph, maximal domain over here, would be x belongs to -infinity to -6 inclusive, or 6 inclusive to infinity, okay? So that is part A. Let's move into part B. Find f dash x and show that f dash x is always bigger than 0 for x bigger than 6. So what does f dash x mean? That is the derivative, so we are going to derive. Now, deriving a circular function, we already have the formula, you already have the format, okay? But it's a little bit different if it's x is on the denominator. So I'll write it down here, write it up here first. Fx, I'll make that equals to y, and I'll just write the equation down first. And what you want to do, you can't just diff this normally, okay? You either want to use chain rule to diff this. So we let u equals to 6 over x, which is essentially 6x to the power of -1. And of course, we let y, in this case, equals to cos inverse of u, because u is 6 over x. Okay, if you want to find dy dx, which is f dash x, we need to find, if you have a look over here, we need to find dy dx. It will be dy du multiplied by du dx, right? Because then the du's cancel out and you have dy over dx. So what is dy du? Dy du is the derivative of cos inverse of u in terms, so we're deriving it in terms of u. So if you were to derive that, there is the formula. It is -1 over square root of 1 minus u squared, okay? So that's just the formula. And then of course, what is the u dx? The u dx would be we derive this formula, right, this equation right here in terms of x, and what you get is -6 x to the power of negative 2 or negative 6x over x squared. You multiply them together to get dy dx. So dy dx. Replace the u with x because you do not want to see u. This is in terms of x. So that is negative 1 over square root 1 minus. So u squared right here would be 6 over x fully squared. So you get 36 over x squared multiplied by negative 6 over x squared. And we're almost there. Negative 6 times negative 1 gives us 6. X squared still in the denominator. And over here, you can have x squared as the common denominator. And what you end up with is x squared minus 36 over x squared. Okay, right, then the next step is you bring the x squared out of the square root, but because it's on the denominator, it will be x squared divided by x. So that simplifies down to x, and it will be x multiplied by the square root of x squared minus 36. And there we go, that is dy dx, which of course is also f dash x. So the first derivative or the gradient of f, okay? Right, so the second part of the questions asks us to show that f dash x is always bigger than 0 for x bigger than 6, right? So what is x bigger than 6? Well, over here, if x is bigger than 6, that would mean x squared minus 36 is always bigger than 0, right? Because 6 squared would be 36, but if it's a little bit bigger, it will be 36 point something, and above 36 point something and above minus 36 would definitely be always positive. So because this is always bigger than 0, that would mean 6 over x times x squared minus 36. This is a positive number. Positive divided by positive will always give you positive, and therefore f dash x is always bigger than 0, okay? So that is part B. Right, and then for part C, guys, I'll do it quickly over here. That is to sketch the graph fx equals to cos inverse of 6 over x. Right, so how would we sketch this without a calculator? I mean, of course, if it's a tech active question, go straight into your calculator, sketch it, make sure you put inside the domain. But if this is tech free, what would you do? So if it's tech free, guys, we want to always find the endpoints, okay? Because we are given a domain. So our endpoints here, domain is negative infinity, negative 6, 6 to infinity, okay? So let's find what negative 6 and 6 is first. So f of negative 6 is cos inverse of negative 1. 6 divided by negative 6 is negative 1. And what you get in this case, cos negative 1 over here, negative 1, that is pi. And then f6 would be cos inverse of 6 divided by 6, so that is 1. Cos inverse of 1 over here would be 0. Okay, so basically at x equals negative 6, y is equals to pi, and at x equals to 6, y is equal to 0. So that is actually an x-intercept. Okay, and these are our two endpoints. Right, then what happens afterwards? I mean, we still don't know the shape of this graph, right? What you can do, guys, is, okay, it's going to negative infinity. So you can actually say, what happened if the graph is approaching negative infinity? If the graph is approaching negative infinity, you would have cos inverse 6 divided by negative infinity. What you get is, because infinity is such a big number, it is essentially another way of writing cos inverse of 0, okay? Because this is such a big number. 6 divided by a very big number, like a huge number, would be 0.000 something, which is close enough to 0. So cos inverse of 0 would be in this case over here, and that is pi on 2. Same thing with x approaching infinity. You get cos inverse 6 divided by infinity, which is very close to 0. So that is also pi on 2, right? So what this pi on 2 is, it's actually your asymptote, because you'll never get 0, okay? Because on the denominator, it's just infinity, it's approaching infinity, so it will be very close to pi on 2. So let's get the graphs rolling. So x-axis, y-axis, we know that our x-intercept is 6, 0, 6, 0. We also know that at negative 6, the y value is pi, so maybe I have pi up here. Negative 6 pi, and then we have an asymptote at pi on 2. So I'll draw a straight line at pi on 2. Okay, what our graph actually looks like. Okay, like I said, as x approaches negative infinity, it approaches pi on 2. So from this point, as x decreases, so it goes to the left, it gets closer to your asymptote. So the graph looks like this. And for this right here on the right hand side, as x increases, so as it gets close to infinity, the graph approaches pi on 2, which is our asymptote. So what the graph looks like is this point right here, or this graph right here, okay? So this is what it looks like, guys, for cos inverse of 6 over x. But that is all of it for the question. Thanks for watching, guys. Leave a like if you found this video useful. But aside from that, thanks for watching, and I'll see you in the next video.